Now we are going to learn some more problems on Newton's laws. While drawing free body diagrams, follow these steps systematically. If a body is having mass, weight acts vertically downwards. If a body is pushing against a surface, normal reaction acts perpendicular to the surface. If a body is connected by a string, tension will act along the string away from the body under consideration. If a body is sliding or trying to slide on a rough surface, then friction acts along the surface away from the sliding. If you follow these steps systematically, you'll never miss out any forces, and then all your free body diagrams will be correct and you'll get the correct answer. Let us look at this problem. This is an inclined plane. There is a pulley at the top of the plane. Mass M2 is hanging here and M1 is on the inclined plane. Let us call this angle alpha. Now we want to find the acceleration of M1 and M2. M1 and M2 are connected by the same string. Therefore, their acceleration will have the same magnitude. Now first, let us draw the free body diagram of M1. So draw a small inclined plane that no one can see, just for our information. And here is M1. Moment I see this, I realize that M1 is having mass. If something is having mass, weight will act vertically downwards toward the center of the earth. So I draw this weight M1G. Then I see that M1 is resting on a surface and is pushing against that surface. So normal reaction will act perpendicular to the surface, away from the surface. Now I look for strings. Here I see a string. So tension will act along the string, away from the body under consideration. Now we look around. For the time being, all our surfaces are frictionless, so no other force is acting on M1. If you follow this step systematically, you will be able to list out all the forces, draw all the forces, and get the correct answer. Now we see that M1 is accelerating up the plane. So we draw the acceleration. Now we have to resolve forces in the direction of acceleration and perpendicular to acceleration. We can resolve forces in any direction we like, but this will be the easiest thing to do, the best thing to do to get the correct solution. We will resolve forces in the direction of acceleration perpendicular to acceleration. Now we see T is in the direction of acceleration. Therefore, delta resolve T. Normal is perpendicular to acceleration. So no need to resolve normal. What is left? This M1G. So M1G will have a component in this direction and another component in this direction. So now we need to know the angles. If you apply a little bit of geometry, you will realize this angle is alpha. If you are not convinced, I can show it to you easily. Draw a line like this here. That is the direction of mg and perpendicular to the surface. This is alpha. This is 90 minus alpha. So this will be alpha. Right? Or other way to look at it. If the angle between two lines is alpha, the angle between their perpendiculars will also be alpha. Any geometry apply, as long as you apply correct geometry, you will get this angle as alpha. Right? Now, we know that the component in the direction of known angle is cos component and the other component is sine component. So this component will be m1g cos alpha because this angle is known, that is alpha, and this component is m1g sine alpha. Very easy. But every time we don't want to break our head and try to find out which is alpha, which is sine component, which is cos component. So for this, remember one simple statement. If this is the angle alpha, the angle of the inclined plane, the component of weight down the inclined plane is the sine component. Other component obviously will be cos component. Now we look at the free body diagram. We are interested in the direction in which acceleration is there. Acceleration is up the plane. Therefore, this force T must be more than m1g sine alpha. So net force up the plane is T minus m1g sine alpha. Right? And this force is mass into acceleration. Newton's second law. Net force equal to ma. So this will be equal to m1 into a. So this is how we apply Newton's second law. Now let us look at m2. m2 is simple, much simpler than m1. m2 is hanging in the air, right? It is having mass. So weight will be acting vertically downwards m2g. Now m2 is not resting on a surface. So there is no question of normal reaction. So don't put normal reaction there. m2 is connected by a string. Tension will act along the string, away from the body under consideration. Right? That is the property of tension. And the acceleration is downwards. Right? That is what is here. So net force is in the downward direction. So net force will be m2g minus t equal to m2a. Net force equal to mass into acceleration. Newton's second law. So now we have got two equations, right? Equation 2 here, equation 1 here. And as I told you earlier, whenever we get correct equations, in most cases, if we add the equations, tension cancels out. Tension vanishes. So let's add equation 1 and 2. You will see that tension will get killed. So what equation you are left with? m2g minus m1g sine alpha equal to m1 plus m2 into a. Just simple algebra, right? So a becomes m2 minus m1 sine alpha into g by m1 plus m2. Acceleration found out. Nothing difficult. Only thing, you should not miss out any force. If you miss out a force, all the work will go waste. Now we have to find tension. So which equation we like? Second equation is easier. So let's take second equation. What is T equal to? m2 g minus a. A is here. So we'll do g minus a. We'll see that we'll get m1g plus m2g. Okay, we're subtracting this. So m2g will cancel out. m1 will still be left. You do a little bit of algebra, you'll get m1, m2, g, 1 plus sine alpha by m1 plus m2. We found tension. This is how we apply Newton's laws to this problem. We applied Newton's second law, drawn the free body diagram and got the answer. It is as simple as that. Now let us look at one more problem on Newton's laws. Both of these are inclined planes. This angle is say alpha, this is beta. And here is a pulley sitting up the inclined plane. There is one mass m1 here and another mass m2 here. Let us assume that the situation is such that m2 accelerates down the plane, m1 accelerates up the plane. Now you have to apply Newton's laws and find the acceleration of m1 and m2, which will be equal in magnitude because this is a string here, and we want to find the tension. The acceleration is equal in magnitude because if this m2 comes down the plane by 1 centimeter, m1 has to go up the plane by 1 centimeter because the length of the string will remain constant. Okay, our strings are inextensible and they don't break. So now let us look at m1. Let's draw the free body diagram of m1. This is the inclined plane. I am just drawing a small line just to be aware that the plane is there. This is m1. And now look how I write the forces. This is something important. You must draw all the forces systematically and ensure that you don't miss out any forces. Any of the forces you should not miss out. Look at m1. m1 is having mass. So weight acts vertically downwards. Any object having mass, weight will act vertically downwards toward the center of the earth. m1 is lying on an inclined plane. So therefore it is pushing that plane. And because of that, normal reaction will act perpendicular to the plane. Now m1 is also connected by a string. Tension will act along the string, away from the body under consideration. For the time being, surfaces are frictionless, so there is no friction. Acceleration of m1 is up the inclined plane. We resolve forces in the direction of acceleration and perpendicular to acceleration. So tension is along acceleration, normal is perpendicular to acceleration. So only thing left is m1g. While solving the last problem, we learned that the component of weight down the inclined plane is always sine component. So this is m1g sine alpha. Straight away we can write. And the other component obviously will be m1g cos alpha. We are bothered about acceleration right now. Acceleration is along the plane. So net force is up the plane. Net force is T minus m1g sine alpha. And that will be equal to mass into acceleration. Call this equation 1. Right? Similar equation we had got in the previous problem also. Now we look at m2. m2 is lying on that side. So we draw this inclined plane, small inclined plane like this. This is m2. m2 is having mass, weight will act vertically downwards, m2g. m2 is pushing against the surface, so normal will act perpendicular to the surface away from the body. Perpendicular to the surface. Now this m2 is connected by a string. So tension will act along the string away from the body. And m2 is accelerating downwards, down the inclined plane. Now again, m2g we have to resolve into components. m2g will have a component this side, that is m2g sine beta. The component of weight down an inclined plane is the sine component. And the component of weight in this direction will be cos component m2g cos beta. So now we are interested in this direction because the body is accelerating in that direction. So net force will be m2g sine beta minus t equal to m2a. Net force is mass into acceleration. So now we have got these two equations. We can add them, then tension will cancel. So let's add the two equations. What do you get? m2g sine beta minus m1g sine alpha equal to m1 plus m2 into a. So here you have found out m2g sine beta minus m1g sine alpha by m1 plus m2, right? So once you got acceleration, you can find tension from any of the equation. Just we need to substitute this in any of the equations. We will find that tension is equal to m1 m2g sine alpha plus sine beta by m1 plus m2. That's all. Problem done. Okay, this is how we apply Newton's laws to solve problems.